All right, let's talk about a moment in database history that really changed everything. It was this single, super elegant idea that gave us the power to slice through absolute mountains of data. We're going to dive into how Oracle basically taught us all how to tame those digital giants, the ones living inside our servers. So let me just start with a question. What do you do when your data gets too big to handle? You know that feeling, right? Your database table just grows and grows until every single query slows to a crawl. And any kind of maintenance feels like you're trying to move a mountain. It's a massive, massive problem. And look, this wasn't some theoretical thing you'd read about in a textbook. As companies started hoarding more and more information, developers and DBAs were actually facing these just unmanageable data giants. A single table with terabytes of data, it wasn't just slow, it was a straight-up liability, a total performance nightmare. But then, Oracle comes along with this revolutionary idea, a way to finally fight back against this data explosion. And they did it with a strategy that was both elegant and incredibly powerful. And they called it table partitioning. The core concept is actually brilliantly simple when you think about it. You take that one enormous table, the one your application sees, the logical table, and behind the scenes, you slice it up. You break it into these smaller, much more manageable physical pieces. We call them partitions. And this is the perfect way to think about it. Imagine you're in a giant library, but instead of organized shelves, every single book is just thrown into one massive, unsorted pile in the middle of the floor. Finding anything would be impossible, right? But what if you organize it by genre? You put fiction over here, history over there, science in that corner. All of a sudden, finding what you need is incredibly fast. Well, that is exactly what partitioning does for your data. So, when Oracle first rolled this out, they gave DBAs a brand new set of tools to start organizing all those books. Let's take a look at what was in that original toolkit. Okay, so this lays out the foundational strategies. The first big ideas. First up, you had range partitioning. This one's super intuitive, right? It's perfect for data with continuous values, like dates. So you could put all of January's sales data in one partition, February's in the next, March in another, and so on. Easy. Then there was list partitioning. This was for discrete, specific values. Think about customer data by region. You could have a partition for North America, another for Europe, another for Asia. Each region gets its own tidy little box. And finally, there was hash partitioning. This one was a bit different. It was all about just spreading the data out as evenly as possible to avoid hotspots on your disk. Really great for things like user IDs, where you just want to balance the load. But they didn't stop with just the basics. Oh no, they also gave us composite partitioning. This lets you mix and match. So for example, you could partition your sales data by month using range, and then, get this, sub-partition each of those months by region using list. Super flexible. And maybe most importantly, they gave us partitioned indexes. This meant your indexes were also sliced up to match your data partitions, which made finding data inside a specific partition, just lightning fast. But believe it or not, all of that was just the beginning. See, partitioning wasn't some feature they just released and forgot about. It was an idea that had to grow and evolve right alongside the needs of the entire industry. So check out this timeline. You can really see how this whole thing builds. It all kicks off back in 1997 with Oracle 8. All they had was basic range partitioning. Then with 9i and 10G, that's when we got the whole initial toolkit we just talked about: list, hash, and composite. But 11G, that's when things got really smart. See, one of the biggest headaches with range partitioning was that a DBA had to manually create the new partitions for, say, next month's data. If you forgot, your whole application could just stop working. Well, interval partitioning solved that. It was brilliant. It created new partitions automatically as the data showed up. A huge, huge step in automation. And from 12c on, it's just been about making it even smarter, even more automated, with really advanced stuff like hybrid partition tables. So the key takeaway here isn't just that they added more options. The real story is that they were making the system smarter. They were taking the burden off the DBA, removing chances for human error, and giving people this incredible flexibility to design a storage strategy that perfectly matched what their data actually looked like and how it behaved. Okay, so this all brings us to the big question, right? So what? What was the real-world impact? Why do we say this feature changed everything? Well, the impact was just massive. Think about it. Queries that used to have to scan an entire terabyte-sized table could now just look at one tiny little partition. We're talking orders of magnitude faster. And managing the data lifecycle, it became a breeze. Instead of running a huge, slow, resource-intensive delete job to get rid of old data, you could just drop an old partition. Instantly. Gone. This made partitioning absolutely essential for data warehousing, for large-scale analytics, honestly, for any system that had to deal with serious amounts of data, even high-volume transaction systems. And this final thought really just says it all. When you're facing that explosion of data, partitioning wasn't just some nice-to-have feature. It wasn't a clever performance trick. For the big companies that were struggling to keep up, it was a lifeline. It was, pretty simply, survival.